This is SpaceTime, Series 27, Episode 16, for broadcast on the 5th of February 2024. Coming up on SpaceTime, the Earth's moon is shrinking, and that means moonquakes for astronauts. NASA's analysis confirms World Meteorological Organization figures showing that 2023 was the warmest year on record. And a new study indicates that stars travel more slowly around the edge of the Milky Way. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed earlier research showing that the Earth's moon is shrinking, and that's causing landslides, instability and moonquakes around the lunar South Pole. Scientists say the findings will have consequences for the astronauts destined to explore and ultimately colonize this part of the lunar surface. The study, reported in the Planetary Science Journal, has shown that the moon shrank more than 46 metres in circumference as its core gradually cooled over the last few 100 million years. In much the same way as a grape will wrinkle as it shrinks down to become a raisin, the moon also develops creases as it shrinks. But unlike the flexible skin on a grape, the moon's surface is brittle, causing faults to form, where sections of crust push past one another. Importantly, scientists have now discovered evidence that this shrinking of the moon's surface has led to notable surface warping near the lunar South Pole. That's the region where NASA plans on landing its manned Artemis 3 mission in 2 years' time. In fact, because of the South Pole's easy access to water, although in a frozen state deep on the floors of permanently shaded craters, the South Pole will become the likely main colonization point for future lunar missions to the lunar surface. The problem is, fault formation caused by the moon's shrinkage is often accompanied by seismic activity, like moonquakes, and locations within or near such fault zones could pose dangers for future human exploration efforts. The authors have already linked one group of faults located near the moon's South Pole region to one of the most powerful moonquakes ever recorded by the Apollo seismometers more than 50 years ago. Using models to simulate the stability of surface slopes within that region, scientists found that some areas were especially vulnerable to landslides from seismic shaking. The study's lead author, Thomas Walters, from the National Air and Space Museum's Centre for Earth and Planetary Studies, says the modelling suggests that shallow moonquakes capable of producing strong ground shaking in the South Pole region are possible from slip events on existing faults or the formation of new thrust faults. He warns that the lunar global distribution of young thrust faults, their potential to be active and the potential to form new thrust faults from ongoing global contraction should be considered when planning the location and stability of permanent outposts on the moon. The study suggests that shallow moonquakes occur near the surface of the moon, just 100 or so kilometres deep into the crust. Similar to earthquakes, shallow moonquakes are caused by faults in the lunar interior, and they can be strong enough to damage buildings, equipment and other human-made structures. But importantly, unlike earthquakes, which tend to only last a few seconds or minutes, shallow moonquakes can last for hours, even a whole afternoon. It means if we're not careful, shallow moonquakes could devastate any future human settlements on the moon. These new findings will help prepare humans for what awaits them when they do move to the moon, and that needs to include engineering structures so they can better withstand lunar seismic activity, thereby protecting people in the danger zones. This is SpaceTime. Still to come, a new NASA analysis confirms the World Meteorological Organization's figures that show 2023 was the warmest year on record. And a new study shows that stars tend to travel more slowly along the outer edge of the Milky Way galaxy. All that and more still to come on SpaceTime. A A new NASA analysis has confirmed data by the World Meteorological Organization that planet Earth's average surface temperature in 2023 was the warmest on record. Their data shows global temperatures last year were around 1.2 degrees Celsius above the average for NASA's baseline period, which is between 1951 and 1980. NASA Administrator Bill Nelson says the studies by both NASA and NOAA, the National Oceanographic and Atmospheric Administration, clearly confirms that planet Earth is facing a climate crisis. In 2023, hundreds of millions of people around the world experienced extreme heat, and each month from June through to December last year set a new global record for that respective month. And July ended up being the hottest month ever recorded. Overall, planet Earth was about 1.4 degrees Celsius warmer in 2023 than it was during the late 19th century average. That's when modern record-keeping began. Meanwhile, the director of NASA's Goddard Institute for Space Studies, Gavin Schmidt, says the exceptional warming isn't something that we've seen before in human history. He says it is being driven primarily by fossil fuel emissions, and we're seeing the impacts of this in heat waves, intense rainfall, and coastal flooding. Though scientists have conclusive evidence that the planet's long-term warming trend is driven by human activity, they're still examining other phenomena that could be affecting yearly or multi-yearly changes in climate, such as El Niño, aerosols and pollution, and volcanic eruptions. Now, typically, the largest source of year-to-year variability on Earth is the El Niño Southern Oscillation Index. It's a climate pattern based around the Pacific Ocean. The pattern has two phases, El Niño and La Niña. During these phases, sea surface temperatures in the Pacific along the equator tend to switch between warmer, average and cooler temperatures. Now, what's been unusual of late is that between 2020 and 2022, the Pacific Ocean saw 3 consecutive La Niña events, which tend to cool global temperatures. Then in May 2023, the ocean transitioned from La Niña to El Niño, which often coincides with the hottest years on record. However, the record temperatures in the second half of 2023 occurred before the peak of the current El Niño event. And scientists say they now expect to see the biggest impacts of El Niño over the next 3 months. But it's not just El Niño. Scientists have also been investigating the possible impacts of the January 2022 eruption of the Hunga Tonga Hunga Ha'ape undersea volcano, which blasted water vapor and fine particles and aerosols high into the stratosphere. A recent study found that the volcanic aerosols, by reflecting sunlight away from the Earth's surface, actually led to an overall slight cooling of the planet by about 0.1 degrees Celsius. That was mainly restricted to the southern hemisphere immediately following the eruption. NASA assembles its surface temperature records using air temperature data collected from tens of thousands of meteorological stations. There's also sea surface temperature data acquired either by a ship or buoy-based instruments. All this data is then analysed using methods that account for varied spacing of temperature stations around the globe and for things like the urban heat effect that could be skewing calculations. Independent analyses by NOAA and by the Hadley Centre, which is part of the United Kingdom's Met Office, have also concluded that global surface temperatures for 2023 were the highest since modern record-keeping began. Now, while these scientists are all using the same temperature data in their analysis, they're using different methodologies, yet they're arriving at the same conclusions. Although rankings can be slightly different between the records, they're still all in broad agreement, and they clearly show that some ongoing long-term warming is taking place and has been doing so over recent decades. This report from NASA TV.
2023 was the hottest year on record by a large margin. But why does NASA, a space agency, even look at Earth's temperature record? Let's start from the beginning. NASA's Goddard Institute for Space Studies, or GISS, creates its global temperature record using land and ocean surface data collected from thousands of instruments and buoys around the world. But this critical data set of Earth's temperature has an origin story that starts 100 million miles away, on planet Venus.
It's 900 degrees hot at the surface, has powerful high-altitude winds, and is blanketed by a dense carbon dioxide atmosphere.
The Goddard Institute for Space Studies here in New York was set up in the early 1960s to provide a connection between NASA and the academic community. And so it was very much an ideas shop, and so we spent a lot of time with, the formation of galaxies and black holes and planetary program and Voyager, and we were involved very early on in some of the missions to Venus and Jupiter.
Back then, when GISS researchers were studying the weather on Venus, scientists noticed something fascinating. A thick atmosphere made up of clouds and carbon dioxide was trapping heat. So much heat that Venus had a surface hot enough to melt lead. This trapping of heat is known as the greenhouse gas effect. One of the lead Venus researchers at GISS, Dr. James Hansen, realized that greenhouse gases were also building up in Earth's atmosphere. So he switched his sights to his home planet and pledged to model the changing atmosphere of Earth. And to verify or ground truth his model, he needed real-world measurements over time. So he began keeping track of Earth's global temperature record, dating back to 1880, when there was a sufficient amount of data to pull from.
We used our expertise in understanding literally the clouds of Venus and the clouds and dynamics of Jupiter, and then we took that and we started to think about how you would do the same thing for the Earth.
Since then, GISS has kept its sights on the global temperature record.
And that was the birth of GISS as a climate modeling institution.
And scientists have seen a clear trend in that record: rising temperatures. And they know why.
The key difference between, say, this decade and the decade before and the decade before that is that the temperatures have been rising because of our activities, because of principally the burning of fossil fuels.
Without the presence of humans, Earth's temperature would rise and fall due to a complex array of natural drivers. With human presence, however, the temperature just continues to rise. We know that by observing temperature anomalies. Measuring temperature anomalies means that we look at the change over time rather than absolute temperatures. The data map isn't showing that the Arctic saw warmer temperatures than the tropics. It's saying the Arctic was that much warmer than the Arctic has been in previous years, which is an anomaly in Arctic temperatures. But how do we get those anomaly measurements? Let's say you want to track if apples these days are generally larger, smaller, or the same size as they were 20 years ago. In other words, you want to track the change over time. Imagine each person on your apple measuring team has their own food scale. Person A measures apple 1, and their food scale reads 6 ounces. Person B measures the same apple, but their scale reads 7 ounces. Since these scales are calibrated differently, your team ended up with 2 different recorded weights for the same exact apple. There's some imprecision in the measurements. And to account for that, when you compare this apple's measurement to the apples growing next year, you'll need to look at their difference rather than absolute weights, focusing on the anomaly or how much heavier or lighter the next apple is from year to year. So for temperatures, while it would be great to have the same exact scale or thermometer all over the world measuring the temperature in the same exact way, we don't. Instead, we focus on how much warmer or colder the temperatures are in each place based on their own instruments. Another factor to consider is since you're tracking apples from all over the globe, there are differences in baseline weights. Let's say apples grown in Florida are generally larger than apples grown in Alaska. Like in real life, how Floridian temperatures are generally much higher than Alaskan temperatures. So how do you track the change in apple sizes from apples grown all over the world while still accounting for their different baseline weights? By focusing on the difference within each area rather than the absolute weights. So when it comes to the temperature record, scientists aren't comparing temperatures in Bermuda to temperatures in Greenland and averaging them together for net warming. Instead, they're comparing the change in temperatures in Bermuda to the change in temperatures in Greenland. Again, we look at the anomaly measurements to track the change over time. Now, let's scale this example up.
If you have a weather station that's, say, here in New York City, and you compare it to a weather station in Washington, D.C. or Montreal, they tell very different stories about the absolute temperature, right? So Montreal is colder, Washington, D.C. is often warmer, but when they move up and down, when there's a month that is warmer or colder, it's basically the same in all three locations. And so by looking at the anomalies, how much warmer it is than normal for that particular point, and then you look at those anomalies at all those different points, and you can average those. It turns out that you can fill out the gaps much more effectively.
This big picture global temperature is comprised of much smaller concentrated data points from all over the world. So while globally temperatures averaged out to be record hot, it wasn't record hot in every single location around the world. But why did 2023 see record heat? Well, to put it simply, a combination of high greenhouse gas emissions and the transition out of 3 consecutive years of La Niña conditions and into El Niño conditions led to record-breaking heat. But the year was, in some respects, still surprisingly hot, and NASA is continuing its research on why. Typically, the largest cause of short-term, year-to-year differences in temperature is usually La Niña and El Niño weather patterns. La Niña generally cools things down, while El Niño warms them up. The largest cause of long-term, decade-by-decade differences in temperature is greenhouse gas emissions and the subsequent trapped heat by greenhouse gases. So while we don't expect every year to be a new record like 2023, we do expect new records as long as we continue to increase greenhouse gas emissions.
The key thing to take away from all of this is that the long-term trends are pretty much relentlessly up. We're going to continue to have records be broken because that baseline is moving all the time. And then the weather is sitting on top of that. And so when the weather is warmer than normal, then we're going to get these records. But even when it's cooler than normal, we don't go back to what it was.
And in that report from NASA TV, we heard from Gavin Schmidt, the director of NASA's Goddard Institute for Space Studies. This is SpaceTime. Still to come. A new study shows stars travel more slowly around the edge of the Milky Way galaxy, and later in the science report, new research shows that people who sit for prolonged periods of time at work have a 60% higher risk of death. All that and more still to come on SpaceTime. By clocking the speed of stars throughout the Milky Way galaxy, physicists have discovered that stars further out on the galactic disk are travelling more slowly than expected compared to stars that are closer to the galaxy's centre. The findings, reported in the monthly notices of the Royal Astronomical Society's journal, are raising the possibility that the Milky Way's gravitational core may be lighter in mass and contain less dark matter than previously thought. The new results are based on an analysis of data taken by both the Gaia and Apogee instruments. Gaia is an orbiting space telescope run by the European Space Agency. It's tracking the precise location, distance and motion of more than 1 billion stars throughout the Milky Way galaxy. Meanwhile, Apogee is a ground-based survey telescope. The physicists analysed Gaia's measurements of more than 33,000 stars, including some of the furthest stars in the galaxy, and they determined each star's circular velocity. Now, circular velocity is how fast the star is circling the galactic disk, given the star's distance from the galactic centre. The authors then plotted each star's velocity against its distance to generate a rotational curve. It's a standard graph in astronomy representing how fast matter's rotating at a given distance from the centre of a galaxy. The shape of this curve can give scientists an idea of how much visible and dark matter is distributed throughout the galaxy. One of the study's authors, Lena Nakib from the Massachusetts Institute of Technology, MIT, says what really surprised the authors was that this curve remained flat, and it continued to stay flat all the way out to a certain distance, and then it suddenly started tanking away. This means the outer stars of the galaxy are rotating a little slower than expected, which is a very surprising result. The authors then translated this new rotational curve to a distribution of dark matter that could explain the outer star's slowdown. They found the resulting map ended up producing a lighter galactic core than what was expected. In other words, the centre of the Milky Way galaxy might be less dense with less dark matter than what astronomers had always thought. The new results, therefore, are in clear tension with other measurements. The authors say there's something fishy going on somewhere. Like most galaxies in the universe, our Milky Way spins, I guess, sort of like water in a whirlpool, and its rotation is driven in part by all the matter that's swirling within the disk. It was back in the 1970s when astronomer Vera Rubin became the first to observe that galaxies rotate in a way that cannot be purely driven by their visible matter. Rubin and colleagues measured the circular velocity of stars and found that the resulting rotational curves were surprisingly flat. That is, the velocity of the stars going around the centre remained the same throughout the galaxy, whether or not they were close to the centre or out near the edge. Their rotational curves weren't dropping off with distance. Rubin and colleagues concluded that some other type of invisible matter, stuff we now call dark matter, must be acting on distant stars to give them an additional push. In this regard, Rubin's work in rotation curves was one of the first strong pieces of evidence for the existence of dark matter, an invisible unknown entity which we know exists and must make up more than 3/4 of all the matter in the universe. Since then, astronomers have observed similar flat curves in other far-off galaxies, further supporting dark matter's presence. But only recently have astronomers attempted to chart the rotation curve in our own galaxy with stars. And it turns out it's a lot harder to measure the rotational curve when you're actually sitting deep inside the galaxy. Back in 2019, Anna Christina Elias from MIT worked to chart the Milky Way's rotation curve using an earlier batch of data released by Gaia. Now, that data release included stars as far out as 25 kiloparsecs, which is about 81,000 light-years from the galaxy's centre. Now, based on these data, Elias observed that the Milky Way's rotation curve appeared to be flat, although with a mild decline similar to other far-off galaxies. And by inference, our galaxy likely bore a high density of dark matter at its core. But this view's now shifted as Gaia's released a new batch of data, this time including stars as far out as 30 kiloparsecs. That's almost 100,000 light-years from the galaxy's core. Now, at these distances, astronomers are looking right at the edge of our galaxy, the place where stars are starting to peter out. No one's ever explored how much matter moves around in this outer galaxy region. It's where we're really starting to touch the nothingness of intergalactic space. So as you can imagine, this study's authors jumped on Gaia's latest data release late last year, looking to expand on Elias' initial rotation curve. To refine their analysis, they complemented the Gaia telescope data with measurements by Apogee, the Apogee Point Observatory Galactic Evolution Experiment. It's measuring extremely detailed properties of more than 700,000 stars in the Milky Way, such as their brightness, their temperature, and their elemental composition. The data is then fed into an algorithm in order to try and learn connections that can give scientists a better estimate of a star's distance. The authors used this data to establish the precise distances to more than 33,000 stars and used these measurements to generate a three-dimensional map of the stars scattered across the Milky Way out to around 30 kiloparsecs. They then incorporated this vast map into a model of circular velocity in order to simulate how fast any one star must be travelling given the distribution of all the other stars in the galaxy. They then plotted each star's velocity and distance on a chart in order to produce an updated rotation curve of the whole Milky Way itself. And that is where the weirdness has come in. Instead of seeing a mild decline like previous rotation curves, the authors observed that this new curve dipped far more strongly than expected at the outer end. Now, this unexpected downturn suggests that while stars may be travelling just as fast out to a certain distance, they then suddenly slow down beyond this distance. When the team transitioned this rotation curve to the amount of dark matter that must exist throughout the galaxy, they found that the Milky Way's core must contain far less dark matter than what they had previously estimated. The result is clearly in tension with other measurements. Really understanding the meaning of this result will undoubtedly have deep repercussions. This could simply be leading to more hidden masses just beyond the edge of the galactic disk, or it could mean a total reconsideration of the state of the equilibrium of our galaxy. You can be sure of one thing: whatever unfolds will be fascinating. This is SpaceTime. Time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that people who sit for prolonged periods of time at work wind up having a 16% higher risk of death from any cause and a 34% higher risk of heart disease. The findings, reported in the Journal of the American Medical Association, are based on research which followed almost 500,000 people over 13 years. The study looked at how much the participants sat at work, how much they exercised in their free time, as well as their health outcomes and any deaths over the 13-year period. The researchers say those who sat all day at work but exercised for 15 to 30 minutes a day outside work had a similar risk of death to people who weren't sitting at work but remained inactive during their free time. The researchers say their study supports the evidence that desk jobs can be harmful to health. Reducing the amount of time you sit at work and exercising more outside working hours can help reduce the risks. A new Australian-led study claims average global temperatures may already have risen by 1.5 degrees Celsius above pre-industrial levels. Aiming to limit temperature rises to 1.5 degrees Celsius or below was the goal of the Paris Climate Agreement struck in 2015. While previous estimates of warnings are based on sea surface temperature records, these only date back to the mid-1900s. These new findings, reported in the journal Nature Climate Change, are very different. They're based on data from species of long-lived sea sponges. These primitive animals contain hundreds of years of data on chemical changes within their skeletons, and this can be used by scientists to estimate temperatures from much earlier. So the researchers used samples of these sponges from species from the Eastern Caribbean in order to explore temperatures over the last 300 years. And they say their estimates show that 1.5 degrees Celsius of warming relative to pre-industrial levels has already been reached. A new study warns that outdoor artificial lighting at night could be linked to an increased risk of macular degeneration, a leading cause of irreversible blindness. A report in the Journal of the American Medical Association looked at some 4,078 patients newly diagnosed with age-related macular degeneration, as well as 122,340 people without the disease, all over the age of 50. After estimating people's exposure to artificial outdoor light at night using satellite data from around their addresses, the authors found higher levels of outdoor artificial lighting at night was linked to a higher risk of developing age-related macular degeneration. While this kind of research can't confirm whether lighting at night causes blindness, the researchers say the findings do add to a body of research showing how much artificial light at night could be impacting your health. It's been revealed that the sleepy eastern English county of Bedfordshire, often described as the country's most boring place, is actually a hotbed of pagan and satanic activity. The title, as England's most boring county, is based on a 2018 YouGov poll of 42,000 people. But what's not so well known is that this same area is regarded as a nexus of sorts. There are deconsecrated churches, strange ancient rock monuments, multiple claims of demonic visitations, and a long history of witch trials and Wicker Man festivals. Even today, it's claimed many villages in the area still have regular black masses and at least 2 or 3 practicing witches. 1,000-year-old May festivals still take place in the region, and one village even has a bizarre Pancake Day witch listening. Tales of the devil stealing children and the souls of the wicked abound. Tim Mendham from Australian Skeptics, who actually lived in this county for some time, says the area was part of the Viking-ruled Danelaw and has a longer pagan history than Anglo-Saxon Wessex, with Celts practicing the Druid religion once common throughout the county.
I, in fact, lived in Bedfordshire for about a year. Yes, so which proves what a hotbed it is. actually,
Oh,
of everything. Bedfordshire is in the middle of England, sort of lower middle. The biggest town is Luton, famous for the Luton Girls' Choir, which doesn't exist anymore. It's not the most exciting.
I'm told it's the most boring county in England.
Yeah, apparently there was a survey done of people. I don't know how many people in Bedfordshire decided that, but there's a lot of hidden secrets in Bedfordshire. It is an old county with a lot of old buildings in it. I think that was one of the ones I lived in was pretty old. It was certainly elite. But what they have town is one person described as sort of that Bedfordshire is known for two things: hat making and Satanism.
Oh, right.
Interesting combination.
Yeah, not two items you'd normally put together, are they?
Well, I don't know what Satanists wear on their head. Maybe they have particular hats that you can only get in Bedfordshire.
Well, you need holes for the horns, wouldn't you?
That's right. I'm sure every county in England, Scotland, Wales, wherever, and a lot of other places as well, have their fair share of ghosts and haunted houses and haunted castles and churches, rundown churches and strange occurrences.
So what makes Bedfordshire stand out?
There's a whole range of sort of strange people who have lived there in the past. Well, more than other places, I don't know. There's characters who are involved in witchcraft and witch hunters and witches and people who supposedly had evil powers over other people and strange occurrences, people coughing up needles and pins and all sorts of stuff. It was actually home, I don't know if it was in Bedfordshire or a neighbouring county, which was the Hellfire Club, which was a famous club of sort of gentlemen of the late 1700s, early 1800s who used to do all sorts of strange things.
Sounds like a gay disco.
Yeah. They used to do it for the hell of it, right? And they were notorious for being debauched. There seemed to be a lot of debauched people. There's a lot of debauched people at the time anyway in that sort of era, people with more money than and plenty of time to do stuff. One of the interesting things is that they actually refer to one of the small towns that I lived in. There was a town called Leighton Buzzard. It's a wonderful name for a town in England. People think it actually comes from Latin Bodazar, but no one's quite sure. But Leighton Buzzard sounds good, which has a church called All Saints Church, which is in the middle of the market town, actually. And it's got ancient graffiti of a basilisk of it and a demon carved into the stonework. Now, there was another church in Bedfordshire, which actually had the devil's footprints in the front step. The trouble is they renovated the church and they removed that, which I thought was strange. Actually, I thought it would have been a great tourist thing. But anyway, Bedfordshire, regarded by surveys the most boring county in England, does have its fair share of strange occurrences and things, and I think that should be celebrated.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.